All right, guys, a little bit more about the derivatives. So it seemed like you did very well with the assignment from yesterday, and we'll just build a little bit on it. And first of all, extreme value theorem, it's very important. If you know that your given function f of x is continuous function on both closed intervals a and b, then f of x has a maximum and minimum on that interval, either at the endpoint or it's at its critical points. And we will learn in a second how to find the critical points. But if you think about an example, if I just graph some random function and notice it is continuous, well, you can graph it however you want. If you put the endpoint somewhere, well, let's say I put the endpoint A here and B here. Basically what I am saying is that between those A and B points, there is going to be both the minimum and the maximum. And well, the way I graph it, it seems like there would be a minimum here and a maximum here. But sometimes if you graph it a little bit different, your A or B, which means your endpoints, could be the minimum and maximum. So right now, for the second example, you will clearly how we can find those minimum and maximums. So notice we have a problem here about a roller coaster, and the height h in feet of a roller coaster hill can be defined by this equation. And again, how beautiful is that? We have an equation that defines a roller coaster behavior, and this is on the interval between 1 and 12, where t is the time given in second, and we want to find the minimum and maximum height of the hill. Well, let's see. So the very first thing that we are going to do is we are going to find the derivative. So this is what you were practicing yesterday. The derivative, we are working with h of t, so the derivative of h of t is going to be, we will bring the 3 in front, so negative 1/3 is there, times 3, t to the power of 2, plus 2 is going in front, so 4 times 2 times t, and then 11 over 3, that did not have a variable, so this is gone. And I am just going to clean this up. This is going to give me negative t squared plus 8t. So this is the derivative. This is the derivative that we solve. Now, if we want to find the critical points, we need to find that we need to take that derivative, and we need to make it equal to 0. All right, so this is the step that you want to remember. You will take your derivative, and wherever the derivative is equal to 0, that is going to be your critical point. Now let's see what happens. So this is my derivative. I'm going to take negative t squared plus 8t, and I'm going to make it equal to 0. This works out really nicely because I am able to factor out negative t. Then I am going to have t minus 8 is equal to 0. It is a nice quadratic equation. And if I am going to use the zero product property, negative t is equal to 0. Well, t is going to be equal to 0, and t is going to be equal to 8. All right, now are those 2 points worth for us to be considered? 0 is not within our interval, so we are not going to be looking at 0 at all. But what we do need to look at is we do need to look at our endpoints. So we need to look at a 1, and then we need to look at 8, and then we need to look at 12, and then we are going to decide, well, what is the maximum, what is the minimum point. So what you will do at that point, so again, this one is not in our interval. Not in our interval, so we are not going to be considering it. But what we are going to do is we are going to plug it into our original function. So I am going to figure out what is h of 1, and that is going to give me negative 1/3 times 1 to the power of 3 plus 4 times 1 squared plus 11 over 3. And I will tell you, because I already calculated that, this is going to be equal to 7.33. H of 8, again, everywhere in place of t, I am going to plug in 8 to the power of 3 plus 4 times 8 to the power of 2 plus 11 over 3, and that is going to give me 89. And I think, well, 89 was, I think, the exact value. And then h of 12, because this is my other endpoint, is going to be negative 1 over 3 times 12 to the power of 3 plus 4 times 12 to the power of 2 plus 11 over 3. And that is going to be equivalent to about 3.67. All right, so again, I want you to see what we did. We haven't answered our question yet, but first we found our derivative. We found our derivative so that we could make it equal to 0, so that we could find the t where we will have either the maximum or the minimum point. Again, this was 8, and I also used my endpoints. I found the value, I plugged it into the original function, and I got my 3 values. What do they tell me? Well, this is the maximum because this is the highest value, and this is the minimum, and this is somewhere in between. So the question was find the minimum and maximum height of the hill. So the graph will have, at 8 seconds, it will be at the maximum of 89. What was the height in? The height was in feet. That was the height in feet. And the minimum will be right here at t is equal to 12, and it will be about 3.67. So that is the extreme value theorem. And again, find the derivative, make it equal to 0, test the value or plug it in into the function, also plug in the endpoints, and then decide which one is the minimum value, which one is the maximum value. All right, now 2 more very important things for today, or again, very important part of calculus. We are going to learn about the product rule. So we are going to find the derivatives of a product. So yesterday, well, let's take a look at the example. Yesterday, I showed you how to find the derivative of something like this. Today, I am going to show you how to find the derivative of the product. Well, somebody could say, well, can we distribute and then find the derivative? Yes, you could, but sometimes you will have examples that are more complicated, and it is just easier to use the formula. So the formula is telling us that if functions f and g are differentiable, which means that you are able to find the derivative, then you will find the derivative of the first function, multiply it by the second function, and then you will add the product of the first function times the derivative of the second function. All right, we will try to follow those steps, and sometimes it's easier to write it out. So, for example, if I wanted to write it out, and some of you may use it, some of you may not, then for me, my f of x function would be the first function. So this would be my f of x. So this is just a function. I am just writing down this as a function. And then the second thing, I am going to write the derivative of this. So again, this is something you practiced yesterday. 3 goes in front, x to the power of 2 minus 2, the 7 disappears. Now, then I am going to take the second one, and I am going to call it my g of x. 3x squared minus 5. And then what is the derivative of this function? 6x minus nothing. Well, I'm going to take that away. So I have both my f of x function with its derivative, and I have my g of x function with its derivative. So what I am going to do is I am going to plug it into my formula, and my formula is saying, so now in general this is going to be h prime of x. The first thing I am taking is the derivative of x, which was 3x squared minus 2. I am going to multiply it by the original g function, which is 3x squared minus 5. Then I am going to add the original f function, and I am going to multiply it by the derivative of the g function. And now, yes, we do have to clean this all up. So for the first part, we are going to use the distributive property. That is going to give me 9x to the power of 4 minus 15x squared minus 6x squared plus 10 plus 6x to the power of 4 minus 12x squared. 6 times 7, 42 x. Please make sure I am not making any mistakes. 6 times 7, 42. Didn't I say that? 42x. Okay, and now let's see. This term and this term has x to the power of 4, so that is going to give me 15x to the power of 4. There's nothing with the power of 3, but then there's negative 15, negative 6, that's negative 21, negative 21, negative 33, x to the power of 2, and then I have plus 42x and plus 10. This is the derivative of the function h of x. If you are ambitious, if you are wondering, you can of course try, multiply it out, and then find the derivative that way. However, again, this formula is going to be necessary, especially when we start working with like a product of a trigonometric function and something else. You will have to apply that formula no matter what. So sometimes it may seem like, well, maybe it would be easier just to multiply, maybe, or maybe not. You can try the other way as well. So this is a product rule. This is a rule that we are going to apply when we have an expression that is that can be written as a multiplication of two functions. All right, well, we did the product rule. Now we need to do the quotient rule. So the quotient rule, we need to have a division. So if we can write whatever our function is as a quotient of two functions, f of x and g of x, then we can find the derivative by applying the following formula. Notice they are fairly easy to remember. So this one is, it's going to look very similar, or the top is going to look very similar like the product rule, except it is going to have a negative sign. So we have the derivative of the first function times the second function minus the first function times the derivative of the second function. And then we are going to divide it by the square of the second function. And what I mean by the second function is the function that is in the denominator. And again, depending on how well you can do mental math, you can do more or less stuff in your head. But then keep in mind it is extremely easy to make a mistake with those. So what I am going to do is I am going to say let f of x be equal to 5x squared minus 3. That is the top function. And I want to be consistent with the notation that the formula is giving me. So then the derivative of this function, 2 goes in front, so 10x. And then my g function is what is in the denominator, so x squared minus 6. And the derivative of this function is just 2x. So now, well, I will just write this underneath. The derivative of the h of, or h prime of x is going to be the derivative of the f function, which we found was 10x, times the original g function, which was x squared minus 6, minus, again, very important, we may have to use some parentheses there. The original f function was 5x squared minus 3, and the g prime was 2x. Again, parentheses are necessary. And then the g function, notice just the g function, which is the original here, needs to be squared. All right, lots of algebra. The algebra skills are extremely important. Let's not make a mistake, because we will have to do it over. Well, I will have to do it over, and it's really late. So let's see. The distributive property, 10x to the power of 3 minus 60x. I am going to be extremely careful with the signs. Negative 10x to the power of 3. And then this would be negative 6x, but because I have a negative sign, I am going to add 6x. And then squaring this expression, x to the 4th minus 2 times 6 is 12, 12x squared, plus 36. Let's see what I have. If we continue, well, sometimes it might be a good practice not to do what I just did, because if you don't, then you can hope for the best that something will simplify. So I just want you to be aware, well, sometimes it is good to do it, sometimes it is not. Let's see if we can clean anything up. 10x squared, 10x to the 3rd minus 10x to the 3rd, that's gone. And negative 60 plus 6 is negative 54x. Well, I can't simplify anything, but it does look nicer in a factored form. Depending on what you will be doing with this question, sometimes it may be a good idea to leave it either way, either this way or this way. So just be aware, well, we have both ways done there. All right, I will give you some nice homework assignments so you can practice those 3 type of questions. Notice that they get a little bit longer, they get a little bit more complicated, but it is extremely important you follow the formula. Make sure you have fun with those. You are doing really, really good mathematics now.